Our next chapter is Basics of Radar. So in this chapter we are going to discuss about what is the meaning of radar and what is the principle behind the radar system, and what are the different frequency used in the radar system, and also the range equation and the maximum unambiguous range, and bit information about the Doppler frequency as well. So first is what is the meaning of radar. So the word radar is the acronym for the radio detection and ranging. And what is the principle of the radar is, in radar system we transmit some electromagnetic wave from the radar and it goes to the target or any object. It intercepts with the target and it reflects back in all the direction. The electromagnetic wave which is coming back to the radar is of our interest. It means that the wave has been traveled two wave, that is from the radar station to the target and from the target to radar. That means it has been traveled, suppose, twice of r if the distance between the target and the radar is r. And the time taken by the wave to travel from the source to radar, from radar to the object and object to the radar is given by distance upon velocity, and the velocity we will consider is nothing but the velocity of light because we are talking about the free space. So in this way we can calculate the overall time, and on the basis of that time duration we can have the range of the target. It not only tells the range of the target, it also tells the object is present or not. So in the radar system we have the two advantages. First, we can have the information about the object or the target, and also the range of the target. That's why its name is radio detection, that it detects the object or the target and it also gives the range of the target, that is radio detection and ranging. And it can work in all type of weathers. Like it can be work in the rainy season, or if there is a very much fog there, then also this system can be used to detect the radar. You can be used to detect the target. So you can write few points here. The first point you can write is the word radar. What is the meaning of this word radar? So the word radar is acronym for radio detection and ranging. So the word radar is the acronym for the radio detection and ranging, and here if you see, this is the short form RADA and R. So RADAR, that is radar. Now the second point you can write, radar gives information about object or target. Radar gives information about the object or target by sending electromagnetic wave to them, and observing the echo signal or the return signal. So we can, the wave which is re-radiated by the target is known as the echo signal, which is coming back to the radar system. So to get the information about the target or to get the range of the target, we transmit electromagnetic wave, and that electromagnetic wave intercept with the target, and some part will be radiated by the target and received at the radar station, that is known as echo signal and re-radiated signal or re-radiated wave, you can write. When the third point you can write, when when the radar signal or electromagnetic wave, when electromagnetic wave encounters a sudden change in sigma, mu and epsilon, what will happen? So we have studied the electromagnetic wave, the plane wave, uniform plane wave, the chapter plane wave propagation, and we have seen that whenever there is a change in the characteristics of the medium, there will be some part of the incident wave that is absorbed by the medium and some part is reflected by the medium. So here also it will happen because we are transmitting that electromagnetic wave. So when electromagnetic wave encounters a sudden change in the conductivity, permeability and permittivity of the medium, some part of incident wave is absorbed by the medium and some part will be re-radiated or reflected, you can write, re-radiated or reflected by the medium. And this re-radiated or reflected wave is of our interest, and by observing this re-radiated signal we can get the information about the target. So this re-radiated energy, you can write here also, this re-radiated energy gives information about the location of target, and its range. So these are the few points that you can consider in the basics of this radar. So this is the basic principle of any radar system. So what we are going to discuss is the important point is that what are the different type of radar system we can have. That is a type of radar system. So first is we have this basics of the radar is biostatic radar. So we are having the first topic as biostatic radar system. So what is the block diagram of this biostatic radar system? So we are having a transmitter. And this transmitter transmits a high power with the help of this transmitting antenna. So this is the transmitting antenna. So we have radiated this high power transmitter with the high power transmitted high power. Okay. So here we are having a target. And when this electromagnetic wave, when this electromagnetic wave intercept with this target, some part of it is absorbed and some part of it will be reflected. So let us say some part is reflected back and it is received somewhere here by the receiving antenna. So by the receiving antenna we received that power. So this is transmitted, after receiving it is processed in the receiver. So it is in the receiver, and we are having a radar display here. There are many type of display in the radar system. We don't need to go into the detail of each type of display, but you can find this display in any standard book of radar. A type display, B type display, O type display. There are many different type of display, and that is important in the point of view if you are preparing for the ISRO exam, then you can get the detail of this radar display, because sometimes they may ask from the question from the radar display as well. So here we are having the receiving antenna. As you can see that this block diagram is having two different antenna for transmission and reception. So that is why it is having name as biostatic radar. So biostatic radar means we are having the separate antenna for transmitter and receiver, or the transmission and reception, because we are transmitting high power by the help of this antenna, transmitting antenna, and after transmitting this we are having the re-radiated signal. This is known as echo signal, and this echo signal is received by the receiving antenna and it is processed in the receiver. So this is the block diagram of monostatic radar system. Now let's consider the monostatic radar, that was the biostatic radar, and now the monostatic radar system. So as its name, monostatic, so we are going to use a single antenna for the transmission and reception purpose. And how it is possible? So it is possible with the help of a device called duplexer. So first of all, we will be having a transmitter at which we will be generating a high power. So we have generated a high power in the transmitter, and in the transmitter, after generating this high power, we have to transmit it. So for this transmission of high power, we are using a duplexer. So we are having a duplexer. And this duplexer is connected to an antenna which is used for transmitting an electromagnetic wave, and here is the target. So we have transmitted this electromagnetic wave with the help of this antenna. Now this electromagnetic wave travels through the free space and go into the target, and in the target it is, some part of it is received and some part of it is re-radiated, and this re-radiated signal, which is known as echo signal, this echo signal is again received by the antenna, and this after receiving we pass it through the duplexer and then it goes into the receiver. And here we are having a radar display. So in this way, with the help of this duplexer, only a single antenna can be used for the transmission and reception purpose. So this is the block diagram of the monostatic radar. So what is the function of this duplexer? So whenever we use in the power in the radar system, so that transmitted power is very high. So during the high power reception, it isolates the receiver so that whatever you want to transmit, it is directly connected to the antenna, and the reception is now disconnected from the circuit. So this is the function of duplexer. It is kind of a switch when you will study in detail in your radar subject. And then you will see that this duplexer is a kind of tube switch, a TR and ATR, we call it as ATR and TR switch. And during the high power transmission, the one switch is closed and other switch is open, and one switch is when connected to this antenna, so the high power is transmitted through the antenna, and it went back, it goes to the target, and when it coming back to the transmitting antenna, that is used for the reception also. So when we received it, the switch which was connected earlier is disconnected, and the next switch is now connected, and that is connected to the receiver at the time of reception. So that power we received and processed in the receiver and display in the radar display system. So what is the function of duplexer? So function of duplexer, is, first, it protects the receiver during high power transmission and the second point is single antenna can be used for transmission and reception. Single antenna can be used for transmission and reception because of duplexer. And the third is, it is used to isolate transmitter and receiver. It is used to isolate transmitter and receiver during transmission and reception. So these are the basics now regarding the radar system. There are few radar system, biostatic, and these are the block diagram of biostatic and monostatic. So there are many different types that we will study, that can be studied, but it is not important in gate point of view. So next we will see that how to calculate the distance or the location of the target in the radar system, and also the frequency which is used in the radar system. So suppose we are having a radar station like this. Suppose we are having a radar station like this. Here it is the radar. Okay. So this is the radar station. And we are transmitting a electromagnetic wave from here, and suppose at any distance r there is a target. Suppose at any distance r there is a target, and this distance is, we are saying it as r. So this distance is r. So as this electromagnetic wave travels from the radar station to target, it travels a total distance of r, and it is coming back to the radar station. That means it is a two-way propagation. why we are calling it as a two-way propagation? Because it is traveling from the radar station to the target and target to the radar station. There are many other signals which may be reflected by the target in this direction, but these directions are not important because we are having the station here. So the signal which is coming back to the radar system is of our importance. So we are transmitting the electromagnetic wave, it travels the distance r and coming back to the same radar station, that is it has traveled now the distance of 2r. So the total time taken by the electromagnetic wave to reach from the source to destination and destination to source is given by 2r. It has traveled the 2r distance divided by the velocity of light, because we are talking about the free space. Now the range of the target is given by r, the range of target, and this is c into tr divided by 2. So the factor 2 comes because of the two-way propagation. So this is the range of the target, c tr by 2, and the factor 2 comes because of the two-way propagation. Now suppose you are transmitting a sine wave for time instant. Suppose you are transmitting a sine omega naught t, and it is going from the radar station to the target, and it intercepts with the target and coming back to the radar station. That means the total time is tr. So you have received now the signal which is t minus tr. This is the received signal. Okay. So this is the transmitted signal, this is the received signal. Now when you take the correlation between these two using the MATLAB software, if you plot this sine omega naught t and sine omega naught t minus tr, that is by the correlation function which is used in the MATLAB, you will see that when you plot it, you will see that some peak value. So this peak value actually gives you the location of the target. So when you on the display or in the radar display or in the MATLAB graph, when you plot, you will see like this. So this particular instant gives you the location of the target. This particular correlation, it is showing the correlation is very high. At this point, the correlation is very high. So from the top, if you will see the dot here, and that dot gives the location of target. You might have seen in somewhere in the display, and when we saw in the movie and in some other channel. So you will see that the radar display, when you see in the radar display, there is some point which is indicating there is some target or there is some object. So how it comes into the picture when we correlate and when we plot it by some software. So we will get the high correlation at that point, and that high correlation shows the location of target. So this is the correlation between sine omega naught t and sine omega naught t minus tr, which gives you this kind of graph. Even although we are not we don't transmit this sine omega naught t, even we transmit the signal which is known as chirp signal. So in the radar system, we transmit this chirp signal. So this chirp signal is transmitted in the radar system practically, but for if you want to draw a sine wave, you can draw sine omega naught t and sine omega naught t minus tr. There will be no problem of it. You can easily draw in the MATLAB. And because this chirp signal is a very, very high frequency signal, so and the representation of this signal is again different. This is sine omega naught t plus 80 square, some kind of this chirp signal. If you will see in the net or the Google, you will find that this chirp signal is not only the sine omega naught t, it is sine omega naught t plus some kind of 80 square is also included. So this type of signal is actually a chirp signal which gives a very, very high frequency. So this is the simple how to calculate the range of the target. Now we have to see what are the different frequency components, what are the frequency range we can use in the radar system. So they are having the different range, and these ranges are important for any defense exam like DRDO or ISRO, and also in the ESE the frequency range is asked, and not in the gate, but it may be asked in the gate as well, because there may be a question of matching of the list, matching list, and in the one side it is given that the band of the frequency, band name, and in the other side you can have the range of the band, that is frequency range of the band. So what are the different frequency which can be used in the radar system? So the frequency band used in radar. So that is the name of the band, frequency band, and frequency range. So that is high frequency, very high frequency, ultra high frequency, L band, S band, C band, X band, Ku band, K band, Ka band, and millimeter wave. These are the frequency band which is used in the radar system, and their ranges are 3 to 30 megahertz and 30 to 300 megahertz, 300 to 1000 megahertz, 300 to 1000 megahertz. 1000 megahertz means 1 gigahertz. So now the L band will start from 1 to 2 gigahertz and 2 to 4 gigahertz. C band is 4 to 8 gigahertz. X band is 8 to 12 gigahertz. Ku band is 12 to 18 gigahertz and 18 to 27 gigahertz, and the Ka band is 27 to 40 gigahertz, and this is 40 to 300 or 3000 gigahertz. 300, okay, 300 gigahertz. These are the different frequency range. So as I have remembered all the range, you have to remember this range as well, because and when I went for the interview around 8 to 9 years ago, so they asked me about the frequency range in ISRO. They asked me about the frequency range of millimeter wave. So this millimeter wave is having the frequency range which is 40 to 300 gigahertz. Okay, so this frequency range can be asked in interview as well, so that's why you should know that what are the different frequency range. And in general, when we perform the microwave experiments in our college days, so in that particular lab, the frequency range which we used in the microwave bench was the 8 to 12 gigahertz frequency range. That means we were working in the X band. So it is still having the as I have taught in the college also. So I have seen in the lab the frequency range still is used, that is X band, that is 8 to 12 gigahertz frequency range are still in use in microwave setup bench and in the labs of the different colleges. So these are the different frequency band used in the radar system. So now we will derive the equation for the radar range.